Hello there, this is exercise 8D.1. There's actually a point 2 where we look at a different version of this, but for this part we're just doing the simple volumes of revolution. I say simple because this used to be on A-level maths and now it's jumped up to A-level further maths, but essentially it's not any different other than the 8D.2 that I'm going to do, which is very much different. So this first part is quite nice, so let's have a look. So we're looking at the volume created when you rotate this graph. Well, an example of it is this one, the graph of y equals x, and the y equals x is a straight line going through 0, 0, 1, 1, 2, 2, etc. But I want you to imagine rotating this around the x-axis. It's a bit weird. This kind of shows that kind of rotation going on. We're going to rotate it a whole turn, and you should be happy to see that if I was to do that I would get a 3D shape, and in your mind I want you to picture that shape. It would give us this cone lying on its side, which we want to be able to find the volume of that cone. And the formula, obviously it's linked to a circle because you're going round a circle, and so for that reason I'm never too surprised. Obviously the area of a circle formula is pi r squared, and it's not quite the same, but it's similar. Volume of this, and its volume not area, is pi times the integral of y squared dx, and between two limits for a to b. So if it's probably the best way to see this is just do a couple of examples. So here's my first example. I've got a curve. It says y equals x, 1 minus x, and that is the curve. It crosses the x-axis at 0 and 1, which is why we're going to do that. And you can imagine if you were to do that, I think you'd get like almost like a rugby ball kind of 3D shape going on, and it's the volume of that 3D rugby ball that I want now to find. And the way we find it is just chuck it into the formula. It's the volume equals pi integral of y squared dx. Now in this case it's between 0 and 1. But I suppose we need to know what y squared is, not just y. And you can quite happily see that would give you x squared 1 minus x all squared. And I suppose I need to tidy this up a bit. It would give me x squared. Well, this is 1 minus 2x plus x squared. And therefore y squared, if I multiply out those brackets, I get x squared minus 2x cubed plus x to the 4. Now this is what I'm going to use then. So it's integral, or pi times the integral from 0 to 1 of x squared minus 2x cubed plus x to the 4 dx. And that gives me pi times pi, and if I integrate this I get x cubed over 3, add the power divided by the power, minus 2x, well this is a half x to the 4, plus a fifth x to the 5. Hopefully I've done that right, between 0 and 1. I always like these ones when you put 0 in you get 0 out, so that makes it a lot easier. Pi times, I'll put this in, I get a third minus a half, 1's great isn't it, plus a fifth, and as I said minus 0. So let's do that, so I might as well do it on my calculator. 1/3 minus a half plus a fifth, and I get a 30th. So this I think is pi, because I've got times it by pi, remember, over 30 cubic units. I don't know what units are, so I'm just going to write cubic units. I'm not sure what my answer says. There, I've just said pi over 30. Done. Anyway, so this is y equals x root x. There's the graph of the new function, and it says rotate this between 0 and 2. And let's get my pen back. Oops. So between 0 and 2, you can see it's here. So it's this bit here, which I'm going to rotate around that x-axis. And so again, I just do the same thing. Volume equals pi integral of y squared dx. So when you get given the equation, it's usually y equals. So you usually will have to do something to that. Y equals x squared. Well, actually, that will become squared, and this will become x to the 1. So this will be y equals x cubed. So this becomes very straightforward. It's the integral from 0 to 2 of x cubed. Hopefully you can see why that is so. Dx. So when I integrate it, I get pi times by x to the 4 over 4, and that's between 0 and 2. Again, put 0 in, you'll get 0 out, so it simplifies things a lot. 2 to the 4 is 16, divided by 4 is 4, so it's 4 pi. That's it. Now, on the exercise 8D, I just want you to do question 2. Obviously, I just do the first column. If you think you need a bit more practice, there's a second column to help you. But that's not the end of it. There's more questions than just that. So we've so far done rotation about the x-axis. And when it was rotation about the x-axis, we had that formula, which was volume equals pi integral of y squared dx. And what we get from there is a new equation for the volume around. So this is the x-axis, which is a bit weird because it says y squared. If I rotate it about the y-axis instead, my formula now switches to x squared. Notice I cared about two x values on my first question when I rotated about the x-axis. Now I care about two y values. So there's a subtle difference here. And they don't always give you the two y values either. They might give you the two x values. So we will need x squared, and we may have a bit of a rearrangement to go on, because again we'll have y equals, which is not x equals. So there's a bit more to do on these. So we've got a new question. We've got y equals 1 over x. Is going to be rotated. Notice it says about the y-axis, which I was just talking about. So, I mean, good news is I know what y equals 1 over x looks like. It's a relatively simple one, so the fact that they didn't draw it for me is not too much of a problem. Now, it looks like that. And what's the x? Between 1 and 4. So 1 and 4 is a bit naughty, really, because they tell you the x values. But you should remember that I need the y values to do this. So the very first thing I'm going to do is I'm going to work out what that value is. And when x is 1, 1 over 1 is 1. Right, that was easy enough. And when x is 4, it's 1 over 4, which is a quarter. So in actual fact, I'm going to rotate this area about the y-axis, like that. And I'm not sure. I reckon it'll look something like this, you know. I reckon it'll look... I think it's going to look like one of those cones you use in PE. Because it's got to have a hole because it's got this gap here. Anyway, so we're going to do it. You don't have to necessarily do all that. So the volume is pi, the integral of x squared dy. Now the first thing to note is we haven't got x. So y equals 1 over x. So obviously rearrange it, gives me x equals 1 over y. And therefore x squared is 1 over y squared, which is probably best written for our purposes, y to the minus 2. So that is pi times the integral of y to the minus 2 dy. And notice the y's agree, so therefore I can do the integration. This is between a quarter and 1. So if I integrate this, I get y to the minus 1 over minus 1. Don't forget the pi at the front, between a quarter and 1. So this equals pi times by... Now if I put 1 into this, well, it's probably best actually if I just think to itself, that means minus 1 over y. Obviously with pi at the front and stuff. So the reason why I prefer that is because now I can put 1 in and understand it. So it gives me minus 1 minus a minus. Now be a bit careful, we're putting a quarter into 1 over a quarter. So that really is 4. So that's like plus 4. I reckon the answer is 3 pi. The answer is 3 pi. Now I've got one last question for you. This is when you do a volume of two, it can be rotated to either axis. This I think should say x-axis. I just saw the question that it should say x-axis. So we're going to rotate what we get from two curves, and it's in between. So x squared plus 6, I know, looks something like this. And 8x minus x squared, well, I'm just going to factorize that. That gives me x, 8 minus x. So that means it crosses at 8 and it crosses at 0. And I suppose we don't really know what they look like other than I'm going to tell you they do somehow cross each other. And they do something like that. I'm not exactly sure where they cross. I suppose we all need to know where they cross. Well, look, the only way you can do that is you set them equal to each other. X squared plus 6 equals the 8x minus the x squared. Whack that over there, I'll get 2x squared minus 8x plus 6 equals 0. I could solve it on a calculator. I'm going to divide them both by 2 instead and factorize. And that gives me x minus 3, x minus 1. So they are the numbers I needed. It crosses there at 1, then crosses there at 3. And it's this area we're going to rotate about this x-axis. So the volume, when you do two of them, is essentially the same, but you just got to be a little bit clever. Let's first of all write 1 and 3, they're the x values. And all I do is I do the one of them minus the other one. I tend to do the bigger one, the higher one, which is the 8x minus x squared. Now remember, I've got to square this as well. So y squared is not this. Y squared is 8x minus x squared squared, which I reckon is 64x squared minus 16x cubed plus x to the 4. So I've got to do that one. And then I've got to also do the other one. What was the other one? It was x squared plus 6. So y squared for that will be x squared plus 6 squared, which is x to the 4, plus 12x squared plus 36. And to work this out, we do the volume of one of them. I'll just call it g of x squared, and I take away the other one, f of x squared dx. So if we do this subtraction, let's get my pen back, it's gone. So if we do this subtraction, well, I've got to do, that's the integral, of 1 to 3. Now g of x, I'm going to say, is this one. So this is what I mean by g of x squared, is this. So I've got to do 64x squared minus 16x cubed plus an x to the 4. That's one of my functions. And then from that I've got to take away this one. And this says x to the 4 plus 12x squared plus 36. Don't forget the dx. So when I do this subtraction, obviously I think x to the 4 minus this x to the 4 cancels. And I get pi the integral from 1 to 3. But I do get some x squared left over. I get 52x squared. So that's them gone. I get a minus 16x cubed. And then a minus the 36 dx. So when I integrate this, I get pi 52x cubed over 3 minus 16x to the 4 over 4. That's 4x to the 4. Minus 36x between 1 and 3. Now I'm going to put this into my calculator. I'll pause whilst I do it. So I've got, when I put the 3 in, I got 36. That's a square bracket. And then when I put the 1 in as well, I got a minus 68 over 3. So obviously what I'm meant to do now is I'm meant to take those away, so when I did it again, I just got pi times by 176 over 3, or probably better written with a number at the front. Good, 176 over 3 times pi. So that's quite a complicated one because you're doing one volume minus the other. And I always do the top one, which was this one, minus the bottom one. But notice this rule, you have to square both of them separately and then subtract them. So I want you now to do exercise 8D, question 4. But again, first column only, unless you want to do 2.